Hey everyone, so today we're going to get into something that's kind of at the core of how the internet even works. We're talking about how these massive websites and apps can handle millions, literally millions of people all at once without just falling over. It's a really cool system, so let's jump right in.
I mean, really, have you ever stopped to think about it? You're streaming a movie, you're shopping during some crazy Black Friday sale, or just scrolling your feed with millions of other people, and it just works. It's so reliable, we don't even notice it anymore. But trust me, it's definitely not magic. It's all thanks to some really, really smart architecture.
So the whole thing boils down to what we call the billion user problem. And look, it's a great problem to have, right? It means your app is a huge hit. But that success quickly becomes your biggest technical headache. How in the world do you actually serve all of those people?
Because, if you try to run this amazing, super popular application on just one single server, one computer tucked away somewhere, you're going to have a very bad day. It's kind of like trying to force everyone from a sold-out stadium through one single little turnstile. The whole system just gets completely overwhelmed, it grinds to a halt, and boom, crash.
So how do we fix this mess? Well, we hire a traffic cop, a digital one anyway. And this is where we introduce the real hero of our story, the load balancer. It's a seriously elegant and powerful fix for the absolute chaos of internet traffic. So here's the big idea. Instead of trying to build one single impossibly powerful server, you use a whole fleet of them. The load balancer then sits right out in front of that whole fleet, and just like a traffic cop at a super busy intersection, its job is to intelligently direct every single user request to a server that's free and ready to handle it. This is how you stop any one server from getting totally overloaded. Now, not all traffic cops are created equal. You've got two main flavors. The HTTP load balancer, that one's like a really smart librarian. It actually reads your request, like, hey, I want to see videos, and sends you to the exact right shelf in the library. But then you have the TCP load balancer. This one's more like an express courier. It doesn't care what's in the package. It just reads the address and gets it there as fast as possible. This is why it's absolutely perfect for things like real-time gaming or streaming, where every millisecond counts. And what's cool is that these load balancers are super flexible. They can send traffic to all sorts of things running in the background. We're talking about your classic virtual machines, which are like having your own server in the cloud, or more modern stuff like container platforms, think Kubernetes, where your app is all nicely packaged up. They can even front serverless platforms where you don't even have to think about servers. The point is, no matter how you build your app, the load balancer is that one stable front door for everything. Okay, so we've got our fleet of servers, we've got our traffic cop out front, but how do people find the traffic cop to begin with, right? This brings us to the second huge piece of the puzzle, the Internet's phone book, which we know as DNS. At its heart, DNS does one simple but absolutely vital job. When you type a nice, friendly website name into your browser, DNS is the thing that translates that name into the numerical IP address that computers actually use to find each other on the network. Just think of it like looking up your friend's name in your phone to find their actual number. Same idea. And connecting your own domain is a pretty straightforward chain of events. First, you just tell your domain provider, hey, use Cloud DNS. Simple enough. Then, inside Cloud DNS, you create a new record. And this record basically says, whenever someone asks for my app's address, send them to the IP address of my load balancer. And just like that, you've connected your easy-to-remember domain name to your super powerful, scalable system. All right, so we've met our main characters, the load balancer and DNS. Now for the fun part. Let's put it all together and watch how they work in perfect harmony. We're going to follow one single user request, all the way from their keyboard to our application and back again. Let's see it in action. Okay, so let's imagine our user. She's in a cafe somewhere in Europe. She opens her laptop, types your app's address into the browser, and hits enter. And right there, the journey begins. The very first stop is Cloud DNS. And this is not just some dumb phone book, it's smart. It sees that the request is coming from Europe, and it intelligently gives back the IP address for the load balancer entry point that is geographically closest to our user. This is so important for cutting down on lag and making the whole experience feel super fast and snappy. So, that request zips across the internet and arrives at the load balancer's front door in Europe. The traffic cop now has the request, but now it has a choice to make. Which one of the many servers in its fleet is going to get this job? And this is really the brain of the whole operation. The load balancer looks at two key things. First, it's back-end services. These are basically the different groups of servers you have set up, maybe one pool in Europe and another in the US. But it doesn't just randomly pick one.
It's constantly running health checks. It's like a medic on a sports team, constantly asking each individual server, hey, you good? Are you healthy? Can you take a request? It will never send traffic to a server that's down or struggling. And here's where it all comes together beautifully. The load balancer sees the user is in Europe, it confirms the European servers are healthy and ready to go, and bam, it instantly routes the request to the best possible server. Our user gets a super fast, totally seamless experience, and they have absolutely no idea about the incredible global dance of technology that just happened in a split second just for them. So now we see how it all works. But, building a system that's truly professional, totally bulletproof, that means following a few key best practices. So let's quickly run through these. First, and this is a big one, secure everything. You should always be using TLS, you might know it as SSL, to encrypt all the traffic. This is just non-negotiable for protecting your users. Second, choose wisely. Make sure you're using the right tool for the job. Is it that smart HTTP load balancer for web stuff, or the super fast TCP one for streaming? And last but not least, you gotta sweat the small stuff. A tiny typo in a firewall rule can literally bring your whole system down, so double check, then triple check your configurations. And why do we do all this? Because following these principles, well, that's the difference between an application that just kind of works and one that is truly professional grade. We're talking scalable to millions of users, secure from all sorts of threats, and resilient enough to handle problems without even breaking a sweat. And that really brings us to our final thought here. Building a system that can handle massive scale. That's a huge achievement, for sure. But in the world we live in today, that's only half the battle. The very next question you have to ask yourself is, okay, my app is fast and scalable, but is it secure from all the modern threats out there? Now that's a topic for another day, but it's the absolute critical next step in building world-class applications. Thanks so much for joining me for this explainer.